Hello everybody, today we're looking at Unit 2, Lesson 1, Length of a Line Segment. So today we're going to kind of build on what we know about the slope of a line and what we know about Pythagorean theorem to come up with a formula that will help us calculate the distance of a line between any two given points. So we'll first start by kind of refreshing our mind to Pythagorean theorem, which we would have saw in the previous day's note. So a TV remote has a range of 7.5 meters. Will the remote work from the doorway? So if we see that the doorway is here, right, so here's my doorway, and we are to draw a line from the doorway to the center of the couch, or sorry, to the center of the TV. Just gonna, okay. So we have a line going from there to there. We can hopefully see that we've created this triangle and they've labeled parts of this room, so we should be able to identify this triangle. So we know that this side of the wall is 3 meters and this side of the wall is 7 meters. So we're essentially trying to figure out, will the remote work from the door to the TV? And it says that the remote has a range of 7.5 meters. Okay, so we're basically trying to see, is that doorway 7.5 meters or less away from the TV, because then it will work. So if we have two sides of a right triangle, we should be thinking we can use Pythagorean theorem. So if we have Pythagorean theorem, we have a squared plus b squared equals c squared. And remember, my hypotenuse is always that side across from my right angle. So I'm going to label this side C instead. Okay, and the other two legs are A and B. So we have 3 squared plus 7 squared equals c squared. And then 3 squared is 9, 7 squared is 49 equals c squared. So we'll continue to simplify this. And then finally, if we need to isolate c or solve for c, we're going to take the square root of both sides. So the square root of 58 is 7.6 meters equals c. Right, so remember, it says that it has to be within 7.5 meters for the remote to work. So since this is 7.6 meters away from the TV, we can say therefore the remote will not work from the door because the distance is 7.6 meters, right? The next question is saying, what about if we were at the center of the couch? If we were from the center of the sofa to the TV, would that work? So the center of the sofa is right here. Let's draw a line from here to my TV and see what that length would be. So now we have this triangle here we're creating. Right, so if we have this triangle, this tiny inside red triangle, we can figure out the side lengths of that red triangle. So we know that this side length here is 1.5. We have to think about what would this side length here be. And we know this is a right angle. Well, we know the full side length is 7. It tells us right here that this little distance to the center of the couch is 1 meter. So if the full length is 7, we need to take away that 1 meter. We can say that this side is 6 meters. All right, and then we're going to use Pythagorean theorem again, keeping in mind this is still our side length C. So we're going to have 1.5 squared plus 6 squared equals c squared. And we'll just work to simplify this as much as we can. Okay, and then we'll need to take the square root of both sides to solve for c. And we should find that c is equal to 6.2 meters. So we can say, therefore, since the sofa is 6.2 meters from the TV, the remote will work. So we've used Pythagorean theorem to essentially answer the question given here. Okay, so we're going to kind of put together, like I said, what we know about slope of a line, what we know about Pythagorean theorem, and that's going to help us come up with what's the distance of a line if we're just given 2 points, right? We're not given the length of side of a triangle. We're just given 2 points on a line. How do we find what that distance is? So let's look at a couple lines here. So let's say we have line AB, this line segment. How could we find the slope of it? Okay, so let's remember that slope is rise over run. So whenever we do our rise over run, we're essentially kind of creating this dotted triangle here, right? So if I think about how much am I rising, it looks like I'm rising 1, 2, 3, 4, 5, 6, and I have a run of 4. Hopefully we can see that as we're kind of figuring out our rise and our run, we're creating this right triangle. So there's some connection there between our slope and this idea of a right triangle and finding the side lengths of a right triangle. But let's first start with our slope. So our rise is 6, our run is 4. So if we reduce that, we're going to get 3 halves. Let's take a look at now if we wanted to find the distance between points A and B. So if I wanted to find what is the side length of this triangle I've essentially created, we know that this is side length C when I'm talking about a right triangle, right? So we would say 4 squared plus 6 squared equals C squared, right? And just again, let's make note of what's the connection here. We can see that 4 represented my run and 6 represents my rise. So then when we're trying to find the distance between one of those sides, we can see, okay, well, that 4 just came from the run and slope, and that 6 just came from my rise of my slope. So 4 squared is 16, 6 squared is 36 equals C squared. We'll continue to simplify this until we take our square root. And we see that 7.2 equals C. So therefore, we can say line segment AB is 7.2. We weren't given any units of measure, so just 7.2. Okay, but you can see that we can take what we know from rise and run and apply that to our Pythagorean theorem. So keeping that in mind, we're going to try to kind of build a formula that we could use here, knowing how do we calculate rise, how do we calculate run. Okay, so let's look at another triangle. Let's say we had triangle CD. I'm going to plot it up here. So if we have triangle CD, point C is at -4. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. That's point C, which is at -4, 5. And then D is at 3, 1, 2, 3, -6. 1, 2, 3, 4, 6. I'm just gonna erase that, it's in my way. And then let's connect those 2 dots to make a straight line. Get our ruler. All right, and I'm just gonna put that rise note back here so it's here. All right, so we have C, and let's label where D was, which was 3, -6. Okay, so it's saying find the distance. So remember, before all we did was we took our run squared plus our rise squared. Okay, so using Pythagorean theorem, a squared plus b squared equals c squared. We know that our a can be represented by our run. Well, our run is there, right? So if we didn't want to put it up on that graph, couldn't we calculate our run? Our run is going to be, remember, our run is x2 minus x1 plus, then we're going to take our rise squared. Well, remember, our rise is just y2, my x2 looks like an exponent, x2 minus, okay, we could do y2 minus y1 squared, and that's going to equal the length of our side squared. Okay, so if I think about, yeah, I could draw this on the graph, I could figure out my rise and I can figure out my run, and that will help me find that side length of my triangle. But let's think about it from our points. So our points here, we have x1, y1, just like we did when we were calculating slope, x2, y2. So to figure out the distance horizontally, or my run, we would do our x values. So 3 minus a negative 4, and then that has to be squared, plus my y values are negative 6 minus 5 squared. So 3 minus a minus 4 is a 3 plus 4, so we're going to have 7 squared. And then negative 6 minus 5 is a negative 11 squared equals c squared. Let's bring that up there. Okay, so a negative 7 squared is 49, negative 11 squared is 121. Okay, 49 plus 121 is 170. And we'll take the square root of both sides. So you should get 13.0 equals, and we can say CD. All right? So hopefully we are starting to see what's that connection between my slope, the rise and run of my slope, in relation to a triangle on the grid. So how can you find the distance between 2 points without using a graph? So we can use the rise and run values from slope calculation and plug them into Pythagorean theorem. All right, so use that rise and run that we know how to calculate. So y2 minus y1, x2 minus x1. Use those values as our a and our b in Pythagorean theorem. Okay, so the distance between any 2 points, so the length of a line segment. So whenever we see length, we should think distance, same thing. Okay, we're going to take, if we had c squared equals a squared plus b squared, right? We're going to take that c squared information, and instead of c squared now, we're going to call it the distance, okay, because we're setting up this formula that we're going to call distance. So distance squared is going to equal that rise, sorry, my run, we can put first, doesn't matter, my run plus the rise difference squared. Okay. So then from there, we need to get distance by itself. Okay, so I'm going to square root both sides to clear that exponent of 2. So now we'll just have distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And if we wanted to simplify that even further, we'll just write distance as d equals. And remember, the x2 minus x1 really just means my change in x squared plus my change in y squared. So we've boiled down kind of how we can connect the rise and run from slope within Pythagorean theorem to find the distance of something. So you're going to want to put a square or a circle around that. That's a formula you're going to need to know whenever we're trying to find the length of a line segment, which is going to help us with other geometric properties in this unit. So let's use that distance formula to find the length of each line segment. We'll do the first one together, and then we'll pause and you guys can try the other one. So find the length of each line segment. So we'll first label these as x1, y1, and x2, y2. Okay, we're going to use our distance formula, so just so we get comfortable using it, let's first rewrite it. So distance equals the change in x squared plus the change in y squared. And so we're going to label this as the length, because remember distance and length being the same thing. So the length of BC is what we're actually using in this particular example. We're going to do our difference in x values first. So negative 2 minus 4 squared plus 3 minus a negative 5 squared. So the length of BC is going to equal. And then negative 2 minus 4 is going to be a negative 6 squared. And 3 minus a minus is going to be a positive 8. And we'll just continue to simplify this. So 36 plus 64, square root of 100. So the length of BC is going to equal 10. We can say therefore. Okay? Take a minute, pause the video, and see if you can find the distance of the line segment AE in the next example. Okay, there's your solution for the length of line segment AE. Hopefully you were able to substitute into that distance formula and work it through to get 7.6 units. Okay, that's all for your note for today.